Hey, my name is Derek Fleck. I do government solutions at Aireon. We're a commercial space company that collects aircraft signals, be it hosted payloads on the Iridium satellite constellation. I'm going to be talking about how you can use space-based techniques to recognize position anomalies and also spoofing events. All right, so the data set that we collect, ADS-B, very good for multi-domain analysis. So you can correlate this with entities from other sensors, objects from other domains. You have the ability to track cargo, personnel globally, thousands of government, military associated aircraft, and obviously it's an open signal, so there's lots of gray zone activity and things hiding in the open. One of the problems with using ADS-B in a geospatial world, though, is that it's dependent. It's dependent on GPS, it's dependent on aircraft avionics to provide that position. When we look at our data globally on the right-hand chart there, that trend line of inaccurate position anomalies is increasing. 2% doesn't seem like a lot, 10 million, 100 million messages a day. You start looking and focusing in a region of the world like the Middle East, and you look at those spikes in last June, last September, or this last March, what that equates to, an impact that really is meaningful, is about 60% of the aircraft in that region at some point during their track are reporting multiple inaccurate positions. So if you look at the headlines, what's the culprit for all this? Obviously, a lot of people are going to point to the cheap proliferation of jamming and interference technology, right? Signal from MEO, a lot weaker than something that's a lot closer. But I think we need to be humble when you're just looking at this data set alone to realize everything of position anomaly and inaccurate positions is not necessarily jamming and spoofing. And of course, there's a lot of unintentional reasons why an aircraft may put out a poor position. Another factor, that may not be an outside influence on the aircraft, right? And there's a way to manipulate aircraft avionics and such that the bad actor may be living inside the aircraft, much like a maritime scenario. So you need other sources or independent information. So when you look at this data set, what are the ways we use to understand positions that are inaccurate? Well, actually in an ADS-B message, avionics itself is providing a level of integrity. So that's an important clue in that data field. We also have the ability, we're not throwing any data on the floor, there's incomplete transmissions where there's not even a position provided, where other ADS-B receivers don't even provide information. That's a clue as well. Displacement jumps, you'll see this a lot of times, huge skips in positions, constant position for something that's not hovering or on deck, right? Or a perfect circle pattern. But really at the end of the day, what you need is some type of independent source. That's the best thing to compare to this position to help you validate if the position's inaccurate. So that goes to the advantage of space-based collection. So beyond the ability to have continuous persistent coverage, low latency, properly architected, a space-based constellation can provide you time difference of arrival techniques, and now you have a way to derive some independent positions from what the aircraft is broadcasting. So how do we do that? Time difference of arrival, 3 key factors for us. So you need timing that's independent of GPS, obviously, if GPS is causing some of these events. You need to know the position of the satellites. And then finally, you need multiple receivers in contact. And with that information, you don't really need the full ADS-B message. If you have an identity and a timestamp, you can start to calculate a position for an aircraft. And so this is my favorite part of the presentation. Now we have a few examples. So in this event here, this is from June of 2025. This is a Russian Tu-154 flying from Moscow up to the northernmost Arctic base that Russia has. In blue there, you're seeing a TDOA-derived satellite track, what we call Aireon vector flight. In red, you're seeing ADS-B positions. And you can see shortly after takeoff from Moscow, those 2 tracks diverge, and ADS-B is broadcasted throughout Finland and also in Norwegian airspace. And then magically, those tracks come back together, and we're even able to track the aircraft into the base when there were incomplete messages in the Arctic. Very similarly, this is a cargo aircraft, an IL-62, from last September. So taking off from Belarus, headed down to Dubai. very similar scenario. The color scheme's the same, right? So in blue, you're seeing a TDOA enabled track. In red, you're seeing the ADS-B positions. Very typical MO of this aircraft, you've seen it before. It takes off out of Belarus. Initially, there's some ADS-B positions presented away from the track. Then a lot of incomplete ADS-B messages that were able to track the aircraft to the east, maybe not perfectly at one point there, but as it turns down to the southeast and it's headed towards Dubai, all of a sudden the ADS-B broadcasted positions are now penetrating through Ukraine. So I would wrap it up and say there's great value in collecting from space for a variety of reasons, one of which is this ability to generate independent positions. And if you have the opportunity to swing by booth 1701 later, we'd love to show you some more examples or talk